My lab here at USC is really interested in understanding sex differences in aging. We got really interested in how the microbiome, which is basically all of the microorganisms and bacteria that live, on our bodies and inside our digestive tracts, how those could influence ovarian function and ovarian aging. We came at this thinking, well, we know there's some communication between the ovary and the microbiome. The reason we know that is because when you have mice that have no microbiome, so we call those germ-free mice, germ-free mice have problems in the development of their ovaries. They're subfertile, and they have a lot of problems in terms of maintaining good hormone levels. We thought, okay, well, the old microbiome's probably not going to have that. It's probably going to make things worse. And so Dr. Min-Hoo Kim, a postdoc in my lab, decided to just take mice and then, wipe their microbiome and either put back young microbiome or old microbiome. And then we looked at various parameters. And very surprisingly, we actually saw that the old microbiota was actually improving the ovarian health, which is super surprising because so far, every time we see something in old animals, it's generally bad, and putting something young improves a lot of phenotypes. And so here, seeing that it actually improved ovarian health was really exciting. When you think about the ease for intervention, probiotics feels like something that's a very low-hanging fruit. You could imagine, identifying exactly which species of bacteria in the microbiome do that and be able to provide them as probiotics for women to help improve the health of their ovaries, right? So even though this is not yet in the clinic, you can see that there's a definite translational potential to those findings if they hold in humans.